3.4, exponential and logarithm functions. So last time we looked at using log properties, and today we're looking at solving equations is going to be the big thing. So we need to remember that logs and exponents are inverses. And when I say exponents, I mean when you have the exponent as a variable, not when we have something like x squared. So this is when we have like 2 to the x power. So logs and exponents are inverses. And so if we have, say, a log of x, we are going to use exponents to solve because those are going to be inverses. And if we have something like 3 to the x power, we are going to use logs to solve. So we are using inverses today. Really want to drive home that point. So here are the first couple problems. These are going to seem a little more familiar. It's a good starting place. So we did problems that were kind of similar to this when we were letting our logs equal 0 and trying to get the same base. So for these first two, we're really going to work on getting the same base. So by same base, I mean I already have a 4, and I know I can make a 16 into a 4. So I have 4 raised to the x plus 2 power. And then on the other side, 16 is a 4 squared. And then I know power to a power I can multiply. So my new exponent will be 4 raised to the 2 times x minus 3 power. And now that I have the same base, I can make my exponents equal. And then I can go through and solve. Let's see, subtract x on both sides and add 6. So 8 is equal to x. On the next one, I start out with a 1/3 on the left, and I know I can make 81 into that 3 as well. So 1/3 raised to the nth power. So we're always kind of looking at the bigger number, trying to make it look like the smaller one, hopefully. Sometimes you have to change them both. 81 would be 3 to the 4th. So 1/3 to the raised to the 4 times 2/3 power now. Remember, we have power to the power again. Both of them now have a base of 1/3. So n is going to equal 4 times 2/3. And so n is going to equal 8/3. So for the next two, we're looking at when we have a log of x. So on this first one, I would always get rid of that coefficient first, divide both sides by 2. I know that you could make this an x squared, but we know that if we have x squared equal to a number, there's going to be like a positive and negative answer. And we know we can't have logs of negatives anyway. So we're going to end up having to reject that negative answer. It will be extraneous. So it's so much easier, rather than having to solve something and making this an x squared, just to go ahead and divide the 2 on both sides right away. So I know that it essentially gets rid of a solution, but it's not a solution that's going to be valid anyway. So short answer is divide by the coefficient, but that long answer is for those students that are like, wait, we can't do that. What about x squared? So divide both sides by 2, natural log of x equals 9. And then because I have a log of x now, I'm going to have to use powers or exponents on both sides. So because this is base e, I'm going to take an e raised to natural log x, e raised to the 9th power. So we've taken each side and we've used that as a power for e. So we have e's to those powers. And just like in the last one, we could take these things with the same base and just make my exponents equal. I'm just kind of doing the opposite of that. Now, the reason that we did this, the reason that we used e, is that our natural log is base e. And we have that property that says if we have e raised to that same log with that same base, it wouldn't have to be e, whatever it is. If it's 2 raised to log base 2 of x, or if it's 3 raised to log 3 of x, whatever that is, if those bases match, it's just x. So I now have x equals e to the 9th power. And I guess we should probably work that out on a calculator as well. I did not write this down earlier. I feel like it's 3,000 something. So let's do that really quickly. Remember, E is almost 3, 2.718. So 8,103.08. It says nearest hundredth. On the next one, I want to take that 4, that's the exponent, and put it in front. So I have 4 times log base 5 of x equals 20. Now we're going to divide both sides by 4. So log base 5 of x equals 5. And then same thing, this is base 5. So now I'm going to use 5 raised to log base 5 of x, 5 raised to the 5th. So I'm raising both sides. The 5's match, so just x equals 5 to the 5th, which is 3,125. So for the next two, we're going to look at what happens when we have logs on both sides. So fortunately, all of our logs are base 2. So we need to take our right-hand side and condense that so we have a single logarithm. So I have log base 2 of 5 equals, these are split apart with subtraction. So I'm going to put them back together with division. So remember, we just write the word log once, and then I have a fraction, 10 divided by x minus 4. So because they both have the same log base, then and they're equal, that means the 5 has to equal 10 divided by x minus 4. So if they have the same base, both sides, you can set the exponents equal. If the log bases like this are equal, we can take what we're doing the logs of and set them equal. I would multiply both sides by x minus 4. And then probably just divide by 5. I could distribute 5, but dividing seems easier to me either way. So x minus 4 is 2, and then we're going to add 4. And so x is equal to 6. So now we have our x's and our exponents. And I've kind of warned you, when we can't get to that exponent, in this case, I don't really have a way of solving for x. When it's my exponent, I'm going to take a log on both sides. So when I had, before, when I had like a log, say, of base 5 of something, I would do 5 raised to that power. We were wanting to get these two to match. So now, because my 3 is my base, I'm going to go ahead and take log base 3 on both sides. So again, we're trying to use that same property where we can essentially cancel them out because they're inverses. So now I have x is equal to log base 3 of 7, which we can't do on a calculator, but we do have that change of base formula that we learned yesterday. So that means log of 7 divided by log 3, or natural log 7 divided by natural log 3. Remember, the ratio would be the same. I just want to pick a log that I can do on my calculator, and this would be 1.77. So on the next one, my x is in my exponent again. So I got to make this so I don't have an exponent. I'm going to have to I'll take a log on both sides. Since I have e being raised to a power, I'm going to use base e, which is a natural log. And because this is base e, these are gone. You know what? I did not write in my natural log on my other side. I better do that. So this should be natural log of 8. So I did my natural log on both sides. Now I have 2x plus 1 equals natural log 8. So subtract 1, 2x equals natural log of 8 minus 1. So notice, just like in the last one, I'm always trying to have that calculator ready form and then the answer. I don't want to take natural log 8 now and do a bunch of rounding and then keep going. I want to have like my perfect exact calculator ready answer, and then I'll come up with the decimal. So here's my calculator ready form. I had to solve for x by subtracting 1, dividing by 2, and then when I use a calculator, I have 0.54. So our next problem is really different. So I do have exponents on both sides, but the problem is I can't make these so that they have the same base. And if I use like log base 3, for example, to cancel this 3 out and get at that exponent, it's not going to cancel out on the other side. So what I'm going to do instead is I'm going to use a logarithm that I can do on a calculator and just take the log on both sides. So I'm going to use natural log just because it's 2 letters instead of 3. And I feel like it'll be easier to write, but we could also use base 10. Some people just don't like natural log. It doesn't seem as familiar because we have a kind of more of a numerical feel for a base 10 log. So what this does is it allows us to take our exponents and write them as a coefficient. So now I have the quantity 6x minus 3 times the natural log of 3. And I have this 4 minus 4x now as a coefficient of natural log of 2. So now I'm going to distribute that. So I'll have 6x times the natural log of 3 minus 3 times the natural log of 3. And my equal signs are just not going to be lined up. There's no hope at this point. On my other side, I have 4 natural log 2 minus 4x natural log of 2. So now I need to get my x's on one side and numbers on the other. So I'm going to go ahead and add 3 natural log of 3 on both sides. Because again, I want all my numbers on one side, all my x's on the other. So 6x natural log 3 equals 4 natural log 2 plus 3 natural log 3 minus 4x natural log 2. And then I'm going to add 4x natural log 2 on both sides. Normally I don't show the adding and subtracting on both sides, but I find in this particular problem, if I don't, people get really confused. So all I've done now is a bunch of rearranging. So my x's are all on one side, and anything that is just a number is on the other. And notice I haven't taken any of those natural logs. I really want my answer to be exact. And if I figured out these right now and started adding them, I'd have decimals everywhere. So we're just going to leave it like this. So now the trick that we're going to be using is to factor an x out of both of these terms. And we've used that trick a lot this year with finding inverses, just doing all kinds of stuff. I feel like we're really expanding our solving skills this year. And now that I have x factored out, I can divide both sides by that big quantity. So I have 4 times the natural log of 2 plus 3 times the natural log of 3 divided by 6 natural log 3 plus 4 natural log 2. Sometimes my natural logs just want to make a mess. It's like I draw the L and the N and they kind of morph together into one letter. So I could certainly in the numerator, I could simplify this. You know, take that 4, make it an exponent, so I had natural log 16 plus natural log 27. I could do all of that, but I don't have to. You can stop right here. I find that often when students try to simplify, they make more mistakes and it takes longer. So I'm going to leave it like that. Just use a bunch of parentheses when you plug it into your calculator. And our answer is 0.65. So your answer might look a little bit different than the back of the book. But if you're getting the same decimal in the end, I would not worry about it. So I will accept this calculatory form lots of different ways. But again, I find that the less simplifying we do, the less we screw it up. We have one last problem. And this probably looks impossible to you, but I want to think about how e raised to the 2x power is really e raised to the x power and then squared. And if that isn't enough, consider if we have, I think the word I want to use is structure. So let's see if you can recognize the structure. So hopefully it's a familiar problem. So I could rewrite this as a squared minus a minus 2 equals 0, where a is really e raised to the x power. So hopefully if you couldn't see it before, you can really see it now that I could solve this by factoring and then using zero product property. The difference is now I'm factoring with e raised to the x power instead. So my two binomials would be e raised to the x power minus 2 times e raised to the x power plus 1. And just like zero product property, we're going to set both of those factors equal to 0. And we'll be adding and subtracting to get e raised to the x power by itself. And because I can't get to the exponent, I need to take a log on both sides because I have the base of e raised to that power. I will take a natural log on both sides. And then we know a natural log and e like that, we're just left with x. But hopefully we remember from before, I can't take logs of negatives. It doesn't make sense. There's no exponent that gives me negative numbers. All that exponents do is make smaller and smaller. They make fractions, right? So even if I have 2 to the negative 100th power, it's just 1 divided by 2 to the 100th power. It's just a super, super small number, but it doesn't ever actually equal 0. So this is going to be extraneous. There's no solution here. On the other side, again, this is base e. This is just going to be x. And this is my calculator ready form, obviously. And then I would also have to figure out the natural log of 2, which is 0.69. So we would want to have both of those parts for our answer. We're always doing calculator ready. You get most of the points for having this, and then usually it's just 1 point extra for having the calculator answer instead. So we're more concerned about the exact answer this year. This is it for our 3-4 notes. Please make sure that you ask questions in class if you have them.